The engine is almost complete. After 8 episodes of screwing and hammering, we're going to place the final part, the cylinder.
The engine case is completed. Now it comes to the mounting of the cylinder. First thing is to remove the gasket, which is too much. We take this razor blade and remove the gasket where we don't need it. Okay, when the surface is smooth, we can put on the first gasket of the cylinder foot. After that, I'm applying this spacer. This is a very special case with this engine because the conrod is more long than stock size. And for this reason I need the spacer and another gasket on top of the spacer. After that, the piston is mounted. The piston needs the circlips on either side. On the side which is not on my side, I did already mount it. On the other side, I will use this tool. It is made from our friends from Italy, from Casa Performance. Before mounting the piston, mount the rings. Place the piston rings at the location at the ring pegs. This way it will be easier to fit the cylinder later on. Then we need the conrod bolt and also the conrod bearing. Now the piston is put to the conrod and the piston pin. Now it's time for the tool for the circlip. Now the circlip is in this bushing. I put this bolt to the bushing, then I put it here. The ring is in its place. Okay, now before we put on the cylinder, we're gonna use two-stroke oil as we burn later on and put it to the surfaces of the piston and the barrel. If you have an aluminum cylinder, normally there's no work needed on the cylinder, but if it's from cast iron, you need to chamfer all the holes of the windows. Okay, now take the cylinder. Make sure the piston rings are in the position of the ring pegs, and then so the cylinder must fit with low force, only by rotating a little bit so that the piston pins get pressed together on the position of the ring pegs. If the ring peg is underneath the piston pin, then you need a lot of force and then you're gonna break the cylinder. So don't do it with force, only with low force. Now it's mounted. We can rotate the crankshaft and see what's happening. This looks fine. With the cylinder applied, I want to show you, usually you have on the roof of the piston, you have a triangular mark, like an arrow that's pointing towards the exhaust port. But in this case, you have no marking, so it's difficult to tell, is the piston in the right position or is it turned upside down? And in this case, you can only see it by the windows you have in the piston and in the barrel. Most of the cylinders of today have a central transfer port, and also the piston has on one side a central window and on one side no window. So the side without the window is the exhaust side and the side with the window is the intake side or the boost port side for the upside transfer. Here's the central window of the cylinder and here's the central window of the piston. Once this is mounted, my personal advice for if you try to make a high performance tuning, you need to measure the timing of your cylinder. But in this case, we will skip that step because it's difficult to explain and not needed for a normal engine. But the least thing you should do is measure your squish clearance. The squish clearance is when the piston is on the maximum top position. We call it the top dead center, and it's the distance to the squish surface in the cylinder head. Not every cylinder head has it, but every modern cylinder head has it. So it's easy to check this. Let's take the cylinder and a caliper, and then more or less rectangular measure the height. It will intrude into the cylinder bore. In this case it's 1.2 millimeters. I am going to write this down, and then I'm going to measure how many distance there is between the piston and the top of the cylinder in the top dead center. For this reason I'm moving it up and down, and this is 2.6 millimeters. So from this 2.6 millimeters I have gap here. I'm subtracting the 1.2 millimeters I have measured here, and this is 1.4 millimeters of squish clearance approximately. Most of the manufacturers give an advice in the manual, and this is a Quattrini kit, and Quattrini says this barrel has to have 1.5 millimeters, so 0.1 millimeter more. So I can either apply a thin gasket here on the head, or I can apply a more thick gasket on the bottom of the cylinder. In this case I'm okay with the 1.4 millimeters. Put the head on the engine and then just tighten it to the next value, and this is the last value on our list. And now the last thing is these aluminum barrels shouldn't be tightened to more than 20-25 Newton meters, while cast iron cylinders you can tighten to more than that. So again, I'm going to use the torque wrench. To finish the measurement and the adjustment of the squish clearance, we take a very soft wire. It's something like welding wire made of Zein, and we put this inside here into the spark plug hole and then turn the engine. For this reason I need the kickstart lever. Now I'm taking a piece of this wire and we'll put it into the cylinder, and the general direction of this wire should be in the direction of the piston pin, because the upper side and the lower side are moving, but the lateral sides are not moving, so this is the best place to take the measurement. I'm putting it inside until I feel the wall of the barrel. Then I move the kickstart engine, and then I look on the wire and I can measure, and the actual clearance is only 1.25 millimeters, so it's a little bit less than what I measured, and that belongs to the press compression of the gaskets. This is why it's important to check the squish clearance once the cylinder is mounted. In this case I will reopen it after the video and adjust it to the proper gap of 1.5 millimeters, because it is very important. If the squish band is too low, you will have knocking and detonation, and the cylinder gets too hot. You might have a seized piston. But if you have the clearance too big, you only have a loss of power, which is not so dangerous and acceptable. Our list is almost filled. We checked the main shaft, the repair kit of the secondary shaft, the silent bushings, the bearings, new oil seals, the main shaft nut, the engine bolts, the clutch cover screws, the the cylinder base gasket thickness, the squish clearance, the cylinder head nut. I didn't measure the cylinder timing, spark plug the flywheel nut. The carburetor is not mounted yet. So this list, which is underneath the video in the description, guided us through the engine and gives us some reference for the next engine we built, and also some reference with the factory values that there are given. For the ignition, please see our ignition videos. Of course, I recommend the ZIP Performance ignition. I hope you found some inspiration and appreciate our efforts. Have a look at our other videos in the channel. Maybe if you leave a lot of likes, we can make another video in this series, maybe putting the engine to the vehicle, or maybe more interesting, going onto our dyno bench with this engine. We can do some performance tuning, change the ignition angles, change the carburation, change the cylinder timing, change the exhaust, and see what the result be in performance. I'm happy you spent your time with us. See you next time. Have success with your engine builds.
Alright, if you missed out on any part of the PX series, don't worry, there's a playlist with all the videos you need. If you enjoyed this video, please leave a like and don't forget to subscribe because there's more to come.